Testing. Oop. Okay, cool. I think I might actually go ahead and start. It looks like it's settling in. Okay. Welcome. My name's Chad Granum. I go by Exodist online. And as of a year or two ago, I am the new maintainer of Test More. That's Test More, Test Builder, Test Simple. Pretty interesting module. I'm sure many of you have heard of it. I want to start by a couple questions. First off, please raise your hands if you have ever done any testing in Perl at all. Okay, that's good. And how many of you have used Test More? Okay, next question's a bit more detailed. How many of you have actually dived in and written tools using Test Builder to play nicely with Test More? Okay, and how many of you know about the level variable, the package variable? That's what I was thinking. Okay. Anyway, before I go into my slides, I'm actually going to show you something that I want all of you to do on any system you can except production, and you will see why in a moment. So right here I've got a fresh Perl brew. The only thing I've added to it is cpan-m. So it's cpan-m dev test more. This is going to pull down test more, the new alpha version. That's why we did the --dev, which will pull in TestStream and install that for you. Goes really quick. There's no dependencies between these two. And I want you to install this so that you can start telling me two things. One, if I have broke something of yours, I want to hear about it and get a bug report, because I don't want to push this out if a lot of people are going to have a bad day when I do. It's also a good idea if you want to message me or send a comment on a ticket somewhere, something to let me know you have something complex, something gross, and it still works with this. That would be really good to hear. Because I get lots of feedback when something breaks, but I'm not getting a lot of feedback of, hey, we tried this and it worked. That would be very valuable to me. So it's really simple. Just this one command and it'll pull it down for you. So moving on. What's wrong with Test Builder? I think these icons tell a pretty good picture. First problem, it's pretty old, which in itself isn't a problem, but it's been a while since it received any real significant development. First release was March 28th of 2001. The last significant feature was added in 2009, and that was when Ovid added subtests. Then came the Test Builder 2 and Test More 2 projects, which got some good initial development, but ultimately petered out. And while those were running, very few people bothered to contribute back to regular Test More, which is a problem Perl 5 actually had when Perl 6 was first started. Same type of problem. The code for Test Builder and Test More has all grown very organically, and it really shows. How many of you have actually tried pouring through the code of Test Builder to see how it works? How many of you nearly lost their minds when you saw how subtests were implemented? Okay. Speed. Test Builder is not particularly fast. There are a lot of places where it could be more efficient. The Perl test suite, when you're installing a new Perl, it takes a really long time, even on new fast machines, even when you do it in parallel. And not everything that you use will benefit from all the features Test Builder gives you. The level variable. Only a handful of you knew about this, and this is unfortunate because it's actually a really important variable. The level variable is used to tell Test Builder how far back in the stack to look for the file and line number to report any errors to. So I'm sure many of you have had a time where you wrote your own tool, such as myOK, that verified a data structure by calling testmore's OK inside of it. It would always report the error to inside your function, no matter where you called it. That's bad. The solution to that was always this big piece of garbage right here that most people don't know about, very few people actually do, and it really makes life easier if you remember to do it. But the fact is, this is a horrible interface. And the fact that we've stuck with it so long is kind of shameful. Okay, syncing. How many of you have tried to do forking or threading in your test suite using TestMore? How many of you liked that experience? That's what I thought. No hands for anyone who's curious. So Test Builder has some basic threading support using shared variables. It's easy to break. You have to load threads first. It won't do it. And if you're trying to fork and run tests in both, you're kind of screwed. There's a few ways to do it. There's test shared fork, which works mostly unless you're doing subtests and it breaks threads. It's just, if you want concurrency in a single file with Test Builder, it's not easy. Doable, not easy. For those of you who have tried to build tools that use Test Builder and actually release them, you might have noticed that you have two real options for testing it. Test Builder Tester, which is painful, and Test Tester, which is a lot less painful but very incomplete. That's a bad situation. I mean, it's very ironic. Test Builder unified the testing ecosystem, but it's very, very hard to test any tool you build on it. So Test Builder also assumed that OK and Diag and a few similar things like that were all any tool builders could ever need, because it lets you generate the basic tap things. Why would you want something more? This unfortunate assumption has caused a lot of problems. If you look at test tools now, many of them will monkey patch OK or Diag or other tools if they don't just take the really drastic replacing the entire singleton. These tools don't usually play nicely together. You really don't know what you're doing, or they don't always know what they're doing, and sometimes they even break the API with their monkey patching. It's not a great situation. And unfortunately, it also makes it really hard to make any improvements because as soon as you do, you break the monkey. So the solution I have been working on is called TestStream. Excuse me a sec. TestStream started initially as a refactor of the internals of Test Builder, but in place, moving things around, not making a whole lot of changes except to put things in a more structured way. It grew into something much bigger, and I've now pulled it out into its own separate distribution, though it might merge back in later. That is one of the plans. So what's better with TestStream? It's new, completely new code base. I mean, some things were refactored from old, but this follows your new modern practices. It's got proper encapsulation. It was written with a goal in mind, and there is a big separation of concerns. It's speedy. Here's some numbers I got. These are running a script that just does 1 million days after making a plan. If you just use Test Builder as it is on CPAN today, this takes around 45 seconds on this machine right here. Instead of TestMore, that is, you replace TestMore with use TestStream, make whatever changes are necessary for that, the same test only takes 36 seconds. That's, I believe that was a 20% speed up. Someone who does math better can correct me. So what I've also worked on is a dev release of TestSimple, the one I mentioned you should install, that changes Test Builder so that it uses TestStream under the hood. And that performance is very, very close to what you already had with Test Builder because of a lot of optimizations that were put in place. So 20% speed up, that's not bad if things were to switch to TestStream. I'm also talking with a few other people, and we might even be able to get these numbers faster than the old TestMore numbers. So either way, in that case, it would be a win-win. Okay, TestStream gets away with level. If you have a Test Builder tool, it'll still work with level, but TestStream itself does not use level. So right here, I'm just going to jump back and forth a little bit here, is a comparison of how you do it in TestStream versus how you do it in Test Builder. Instead of bumping some level variable and localizing it and getting your math right, you simply say, hey, give me a context. This context is now in play until you release it. It knows what file and line was just above you. Any tool you call nested within your tool will find that context, and it'll just know where to report errors and things like that. Context also does a lot of other things I'll get into on a later slide. But anyway, this is a simple tool, myOK, calls OK, returns the output after giving some diag if the test had failed. A few people have had to do this. So let me just jump back to that legacy one. Localize this giant variable and do some math, which usually one, but not always. Or just say, hey, give me a context. Oh, by the way, down here, I'm done with it. Please release it so that a new one can come. I'll take questions at the end. Syncing. TestStream was designed with concurrency in mind from the ground up. It works with threads, it works with forking. Subtests work in threads and forking. You can fork before the subtest or inside the subtest. It'll get it right. It just works. There are tools built into TestStream for testing your testing tools. That is quite a mouthful, but you no longer have to worry about writing tests that are super fragile or using tools that really make you not want to write tests. Tooling. TestStream does not assume all you need is OK and diag. It assumes that you're going to want to do a lot of fancy stuff, want to play nicely with other things that do fancy stuff. So, all results are events, and there are lots of hooks into these events. You just build your event and you send it off, it goes and does its thing. Let's see, there are hooks for modifying the event before they are even used to adjust the state, and there are hooks for seeing the event after all state has been updated. With the modify hook, you can actually even stop an event from continuing, so you can remove events if you wanted to. Tap is the default output, but you're not married to tap. You can write any formatter you want. It's just a simple object with a write method that takes events. Skip the events you don't care about, log the others to a database, put them out in a new version of tap or whatever you want. Let's see. So yes, we hook all the things. TestStream has hooks all over the place. That's one of the goals. If there's a place where people could feasibly want to do something and it doesn't cost us any performance or other important things to add a hook, we're going to add that hook. Most of the ones that are in there now were added so that we could actually make Test Builder use TestStream under the hood. Unlike Test Builder, we don't have some monolithic singleton that is your only point of entry. This puts as little as possible into a singleton-like place. There's no place where you can't do something without monkey patching. File a bug and we will add a hook or find a way to make it so you don't need to monkey patch. Okay, so now I'm going to go into the architecture. First off, the philosophy of the architecture: never assume what people want. Provide tools to build solutions, not solutions in of themselves. Hooks are better than predictions, and we don't want to be locked into limited ideas. We're going to be strict with all our new features, and we can relax them later if we need to. It just makes it a lot easier to focus on whatever. So these are the key components of a TestStream existence when you load it all up into memory. There's event objects: OK, diag, note, plan, all the things you're used to doing with Test Builder. They are now event objects. Hubs. Hubs are what do the primary routing of the event. The event goes into the hub, it gets through the mungers to possibly remove it or modify events, goes to the formatter, modifies state, and then ultimately goes to listen hooks. Then the event's gone, doesn't matter anymore. Could have stored it, whatever. There's the IPC. This is where the concurrency happens. We've got an IPC driver system. Right now there's only one driver, and that's using directory, because that is a universally usable way to transfer messages between processes. But if someone wanted to write one that used, say, IP sockets, it's easy. Well, maybe not easy, but it's doable. Okay, hub stack. Hubs are not singletons. Hubs exist in a stack. You can push new hubs on top whenever you want. Whatever hub is on top of the stack is the one that's going to receive the events. This is actually how subtests are implemented. Start a subtest, new hub on top to get all the events during that subtest. When you're done, you pop the hub off and report a final event to the hub that was under it. This is also useful for testing, because you can pop a hub on, intercept all the events, and then verify you got all the events you thought you would. So, details about the event objects. Here's the main events. These aren't the only ones, but they're the ones everyone knows about. OK, diag, note, plan, bailout, subtest. You can add your own events. All you have to do is subclass the event class. It does a bit of magic for you, and you've got your event. Anything that doesn't know that event should be smart enough just to say, oh, ignore it. If you wanted to put in some event like, oh, the time is now midnight, you could actually do that event. I don't think that would be particularly useful, but it's there. Hubs. Hubs are very small and very light. Got to keep this package small because it is really the process that every event has to go through. If this thing were big and bulky, it would make for some very slow code. But it is also what provides you with most of the points at which you are going to want to hook into TestStream. Things it does for you. It understands, oh, I just got an event. It's supposed to go to this hub. Oh, but this hub isn't in this process. This hub was started in that process. Let's write to the IPC system so that other hub can pick it up. So you don't actually have to think about that part. And like I said, hubs are not a singleton. You can have as many as you want, create them, destroy them, whenever. Doesn't matter. Hub stack, I think I've pretty much covered all of this already. The hub stack is not itself a singleton, but there is a canonical instance kept in one place for, and that we go over here in the sync. There is a single package, TestStream sync, that holds two variables, well, three variables of importance. One is the global hub stack. Unless you specify you want to use your own stack, most things will default to that stack. It also has the canonical IPC instance, because IPC is not particularly useful if every process and thread uses a completely different instance of it. Some of you may know that test builder has logic, so that it will set the exit code to however many tests failed or 255, whichever is lower. That is done in an end block, sadly. That end block exists in this package. This package is not actually an object. It is some lexical variables that are closed over so that no one's going to come in here and actually try to replace your instances of them. We're forbidding that right off the bat because that is not playing nicely. Context. The context is one of the first ideas that came from TestStream, and it has proven to be one of the most important. Context serves as your map, your GPS, your compass, and as the primary API for firing off events. There's one instance per hub. Each tool will generally get, if you nest tools, they will get their parent's instance. And if you want to fire off an OK, you would get your context and say context OK, or context send event OK, here's the parameters. It tracks the file name and line number for you. It understands whether or not there was a to-do setting in play when you started it. It just does all this stuff for you, and it's really nice. And it's actually an object you can put methods on, so you actually have this information. It's not buried in the guts of test builder somewhere. Let's see. Okay, so I'm going to go to my more information slide, and then I'm going to do some live coding, and we're actually going to try to build some tools here and test them just to show how easy it is, how much it has changed. So first off, the plan. Right now we're in the experimental phase. We actually came close to a release shortly after the Berlin hackathon. But then when I actually started building some tools on it, I found some shortcomings and some bugs, and I realized it would be irresponsible to release this without getting some period where people actually try to use it and tell me what sucks about it. So we have entered the experimental phase. The TestStream dist that is on CPAN right now it has documentation saying, hey, this is experimental. I would love it if you would download it and try to use it, try to build simple tools on it. Come back to me and say, hey, this really sucks, or this could be done better, or this just doesn't let us do what we need to do. I really need that feedback, and as soon as I stop getting that feedback, as soon as my tools all work great on it and I don't have any more things to fix from people, that's when I'm going to consider it pretty much stable, at which point we move to the punch list phase. Punch list was something that was created at the hackathon in Berlin. Toolchain group came together and came up with a list of requirements that Test Builder and TestStream had to pass before I publish a stable release of Test Builder with TestStream under the hood. And once that's done, TestStream will probably merge back into Test Simple, and it'll probably go into core Perl. So once again, please run your test suites against this. Please make sure it works, because if it doesn't, your stuff might explode someday. Stable phase, that's when all that's happened, and we're done. Okay, so moving on to live coding. Let's start with all the, well, let's first write some tests using TestStream instead of TestMore. There are actually a few API changes. You can't just remove use TestMore and replace it with use TestStream. You might be able to for a lot of tests, but there are a few API things that people complained about that I decided, since it's a new namespace anyway, let's fix them. So use TestStream. That will load you strict and warnings for us, just like Moose does. Thank you. Problem with live coding. Okay, so now we're going to plan. You can no longer set a plan, use TestStream, because that actually proved to be very limiting. It made it so you couldn't make a whole lot of different arguments. Importing exactly what you want was complicated. And there's also the fact that it happens in a begin block that makes a lot of hooks and other things extraordinarily difficult, because begin blocks are very special. So let's plan 2 tests. Do OK 1, pass. OK 2, pass again. OK, now let's just run this. Easy, just like using test more in that case. So let's see what happens when you fail. Same thing you'd expect from test more. It gives you, oh, we failed this test, and it's at test PL line 5. Let's go ahead and wrap this, actually. OK, so let's call my OK, and we're going to see the problem that a lot of people had with Test Builder. Oh, look, where is our failure? Line 6. What's on line 6? Oh, it's inside our sub. OK, what about this? Look at that. We failed on line 6 like 6 times. That's not very helpful. Context is not exported by default, because most people do not need it. Always release when you are done, because there are some hooks called. OK, where is it? Ah. There we go. So now we failed on lines 11, 12, 13, 14, and 15. 11, 12, 13, 14, and 15. So we're reporting to the right place. That is because we created our context here, and then inside the implementation of OK, where it does the same thing, it gets the instance we already have. And then here we're releasing it. And so when we get down to the next tool, there's no context, and it generates a new one at the proper file and line number. Release gets called inside every the nested tool. So OK gets the context, and then it also releases it at the end. It is smart enough not to release it early. It pays attention to the ref counts. OK, so let's say we want to test my OK. Make sure it works right. Use TestStream tester. Pretty obvious name, I think. OK, let's start easy. So we're going to intercept all the events here. This. OK. Oh, I did that totally wrong. Who knows what I just got wrong? OK, there we go. OK, so we are going to see no tests run, because I just intercepted every test that was run inside this intercept code block here. But just intercepting them still leaves you with something that's not particularly easy to test. So what we have here is all the event objects that came through. So it's blessed as an OK event. Here's our to-do and where to report errors. There's the name, pass, all that stuff. Still, that you could throw in as deeply on that, but if there's a problem, the debugging isn't all that great. So let's change this again. Events are typing in front of a lot of people is a lot more difficult. OK, then let's say events. Let's just go ahead and name this so I don't forget to do that later. Got our events. There we go. So this is a special code block wherein we can declare what events we expect to get. So let's say event OK pass 1. We're going to do the fields we care about. We don't have to list all the fields, but we could list any fields. This test is going to fail because I expect both those OKs to pass, but we already see that one won't. So this test failed, and look at all this diag it gave me. It said inside our structure, the first or second event, so index 1, pass, should be, we failed to check that 0 is 1 because we expected 1, but we got 0. This diagnostics message is very rough. There are plans to improve these diagnostics. This is just the first pass. OK, so it says, look, the event was created on line 16 of TestPL. Let's take a look up here. Yep, look at that. Line 16 of TestPL, that is the event that was wrong. We don't have to go through our whole data structure and figure out, okay, which one was wrong. It is telling us the exact line number of the problem. Let's go even further. Okay. Sub. What happens if you define an event as a sub? Well, we can do this. I actually forgot this. I've got to look up the documentation. Thankfully, I have good documentation. If I can get to it. What the hell? My numlock is on. TestStream. Like I said, it's on CPUN, thankfully. TestStream. Yes. TestStream tester. Experimental warning. There we go. Okay. For the sub version. Oh, did I? Yes. Okay. So here's some examples here. Event call is calling a method on the event to check it. So let's see what pass should return is 1. It returns 0, but we want pass to return 1. Event line. Well, this event should be on line 8. Event file. Should be our file. Easy enough. Let's see, what else do we want? Event field. This will do a defective pass. We also want that to be a 1 because it should pass. Okay. Notice that what we have here, it says, hey, look. Okay, so line 14 is where we declared our events, and line 18 is where it says, hey, our event line is wrong. We got line 13. Yep. We said we wanted line 8. That's actually not true because we called myOK. This is a case where someone wrote a test that was incorrect. Let's fix that. Line 13, where we actually called myOK. Now we'll get past that one. It says, oh, but now pass is wrong on line 17 in the event defined on line 16. So event line 16, and I already forgot that number, 17. So yes, pass isn't working. You'll notice those got called out of order. It detected that event line was wrong before it detected event call. That is because this has 3 separate phases. First, it'll check the metadata about the event, such as line and file number. Then it'll check the hash stuff, or sorry, the object stuff, which is when you're calling a method on the object. So pass comes next, and then it checks the hash field. So it goes in. This should be 0. Okay, now we got another problem. Effective pass on line 20 broke. Here we go, line 20. Now, this should all just work. We got all our events. Now let's change something here. Let's add a 3rd event. This will still pass because we're only listing 2 events. Maybe not. Line 19. Not quite sure why that happened, actually. 1 person at a time, please. Thank you. Okay, so it still passed because it only checks the events we tell it to care about. If we really want to make sure it's only the events we care about, end events. Now it'll fail because we got another event. And let's see. There is actually some stuff missing from this. It's also supposed to give you diagnostics of where the event came from. It should tell me, oh, there's an event missing. It was from line 9. That diagnostic isn't showing up, so that is a bug that I've just discovered live. Okay, let's say, though, we only want to see our passing tests. We don't care about failing. This would also work if we don't want to see any diagnostics messages. So end events, just like this, it's going to fail because we got 2 extra events. But what we can do, filter events. I think this takes a code block. There. Too many arguments for filter because I did not end it with a semicolon. There we go. There. It says we passed because I filtered out all events that didn't pass. You can also filter out all events that are diagnostics, which is really useful if you're getting diagnostics or events generated from something that's not under your control. That's their job to test it, not yours. This way you can care only about the events you're generating, so that if they decide to change how theirs works, your tests don't fail because of it. This is a big issue, because the thing that actually spawned TestStream was a change request from David Golden, who gave me permission to mention him here. He wanted to change the indentation level of the comment that tells you you are entering a subtest. This is a message intended purely for humans. Machines don't care about it. It is a comment, so TAP doesn't care about it. It's just changing how far along this human comment is. Tons of things, because most tools that actually bother to test whether they're doing the right thing take a big giant string of TAP that is produced and do EQ on it to make sure it matches the string they expect. This broke a bunch of downstream tools. By the way, Test Builder Tester, this is the way it works. It does giant string comparisons. You should not be able to break tons of things just because you change the indentation of a message for humans in your test. And this solves that problem. By the way, that changes in here. The indentation's different for those who actually care. But this testing ability is one of the first things that TestStream cared about. It's like, let's make it possible to test tools. Let's make it easy to test tools. Let's make it give you good diagnostics so you're not searching for the point in the data structure that's wrong. And let's really encourage people to test their testing tools. Let's see. I think I've gone way under time by shortening my presentation that used to be too long. So I'm going to start taking questions. Questions can be answered by live coding if desired. Let's see, hand way over there came up first. You could do no warnings. Here, let me show you. Oh, yes. He asked how you can turn off warnings if TestStream loads it for you. That's pretty easy. Done. Only if you use TestStream. And this is still the experimental phase. We're throwing a lot of stuff at the wall and seeing what sticks. If you actually have a valid complaint that turning on warnings in new code is a problem, we'll look at it and we'll weigh, okay, maybe we shouldn't be doing this. Moose decided to do it. They're still doing that. That might just be a back compatibility thing. At this point, nothing is set in stone. I want feedback, like what you just gave me, to try and really make this shine, make this better than it already is. Next question. I think yours was second. That's actually how it worked until about a week ago. And the reason is because of those hooks. Something we can do here on release, hello world, and add the missing brace at the end. Okay, so when we release our comment, it prints hello world. Something else someone might want to do. Note, there's tests failing here. Let's say you want your test suite to bail out as soon as any event fails. You can't just bail out the moment the OK happens, because then you're possibly missing some diagnostics the tool wants to go out, which is why we don't have this feature yet, despite it being in a bug for like 8 years now. You could actually write that here. But let's say we die foo. No. OK. So here we died. We died foo at line 7. If this just did it automatically in a destructor, die foo would be a no-op. You might get the warning, but your test suite won't die. Because if you die in a destructor, it doesn't work. And so we have release as something you explicitly call instead of let happen automatically, because we want people to be able to implement this functionality that has been requested for 8 years. Having release now does not prevent us from removing it in the future if we find out it's too burdensome and doesn't actually add any value. But if we wanted to add this later, we couldn't. It has to be in from the beginning. Yes, it could go away in the future. Yes, it is possible to have it release automatically when the ref count runs out. It did that for months. But I needed this hook. This hook was necessary for a couple things, especially that 8-year-old bug. I keep getting that date different, but it's somewhere in that range. And so that is why it is there. Next question. You. Yeah, you. Okay, so the question is, calling your contest deeper than just a level up? The answer is quite simply there. You can set the level and the call to context if you want. Though the preferred option would be to call context at your actual entry point and then run your nested stuff and then get it again deeper, because it'll find the one that's higher up, which is better than trying to do the math. But if you can't, if you don't control the thing that's calling yours, you can use level like this. Did I repeat that question? I think I did. Okay, next question. Okay, the question was, how well does this play with test class? Well, I've got it installed on this system. We can actually find out, and I've already done this, so I know the answer. The answer is it just works. Test class works on what we have currently with the test builder dev and the TestStream dev. In fact, I've got about, I've got a list of downstream things I test every time I do a new test builder release. It pulls in Moose, Plaque, Catalyst, Diszilla, enough stuff that it practically installs half of CPAN. It installs all of the useful CPAN. And as of the versions that are on CPAN right now, all of them pass. So yes, there, test class just installed properly, no issues. It just works.
In your slide concerning the performance, I was a bit confused as to whether some features of TestStream were faster than Test Builder and others slower. And I was a bit confused about that because several months ago when we were testing this, in view of the possibility of it going into Pro by Core, we said that the TestStream-based code was running basically 17% slower than the existing code.
Question was confusion over the performance, because in the past people have benchmarked this and had very different numbers than I'm showing here. This is the third re-architecting of TestStream. The first re-architecting, or the first TestStream version, actually took an entire trace of the call stack every time you called one of its methods. This resulted in taking twice as long for just about anything it did. It was bad, it was miserable, it was the wrong way to solve the problem. That's when the context idea came up and instantly changed it so it was only 30% slower than Test Builder, which was still not acceptable, but was a pretty significant improvement. From there, we were able to do a bunch of optimization and ultimately got it down to basically parity with Test Builder. Someone who was actually in this room was actually able to enhance it enough that it was faster than the original Test Builder. Those didn't all get merged, though, before I found a flaw in that architecture as well, which is what caused the latest significant changes that led to the hub stack and the sync module. Basically, it was a flaw with how subtests work. They didn't inherit all the right hooks. Kind of a mess. This all works. I don't foresee another architecture change, but like I said, nothing's locked in stone. We want to make sure this is right. I'm not just going to push this out because, hey, I think it's done and it works for me. I want to make sure this works and that people have actually tried building stuff with it. That said, please, if you are a test tool maintainer, don't go out and convert your tool so it already depends on what's on CPAN, because I will be breaking it a lot if I need to. For now, what you might do is create a branch or an entirely new module that forks it, that uses TestStream under the hood, and then turn that into your main branch once TestStream is stable. Because we really don't want, or I really don't want anyone to accidentally put this into production right now, because as documented on CPAN, I do foresee breaking API here and there with the TestStream release for the next couple months. Once the unstable phase is over, that will change, and I will not be breaking API compatibility. Unless I really, really have to. Next question. That it? Okay. Well, I still have, if you guys want to just end the talk now, I guess that's okay. But I do have other stuff I can show. Let's see here. That's probably not a good one to show. Okay, so deep check. With TestStream, you still have is deeply, but under the hood, it's implemented differently. you can still do it just like before. So like strict compare is basically as deeply. There's a relaxed one which will ignore anything you don't actually care about. You can say, oh, hey, look, I don't care about this, so I'm not going to list it in my what I want, and it'll just skip over it. This is the relaxed is deeply, which a lot of people have tried to do here and there, and this is my take on it. But you also get declarative keywords, much like I showed you for TestStream tester. So you can say, oh, hey, this should be a hash. It should have this field, which is an array, which has this element, all that. And it's declarative so that if it fails, if something is wrong, it'll tell you exactly which in your expected structure the missing bit or incorrect bit is from. You don't have to go searching through the whole data structure. Yes, it's a bit more verbose when you're writing your test. I think that's a fair trade-off, because this way, really, another thing I can mention, which is a neat trick, at least I think it's neat. So how many here have played with B, the B module to inspect things? Very few. Okay, there's a few more than I thought. With B, you can take a subref, a code block, and say, hey, what line number and file name did this code block come from? And it'll give you the file name, and it'll give you the line of the first statement within the sub. It's kind of flaky, so it's not actually the line that started the sub, but pretty much the first line inside the sub. That only gets you first part. So like for instance, this hash, if this hash were wrong and we only, it would report this line down here as where the failure was. Neat trick. Hash here is a sub that takes a code block. It goes in, code block, it says, hey, what file and line number? Great, now we have the last line number. But this is a function, so let's call caller, which will give us here, where it was called, which is, or I'm sorry, I got it backwards. B gives you the first line, so we get this line from B, and then caller gives you the last line of your call to the hash function, which is here, possibly here, but mostly here. And roughly the last line of how this hash was defined. So we can actually say, hey, this structure failed in the hash that was declared from line 6 to line 10. And it tells you somewhere in between those two lines you did something wrong. And then the actual failures say, oh, and it was in field bar defined on this line to this line, in the element defined on this line. And it gives it to you in a nested way, so you have much better diagnostics for saying, hey, where'd this go wrong? Yeah, I'm missing element A from this nested structure, but where'd that actually happen? This tells you. Oh, and here's that example. And you already saw this in practice with TestStream tester pointing it out. If it doesn't know the line number, it'll give you a dash dash after giving you what it knows. If your structure goes across files, like you're calling a callback from another function, it'll actually list that file just before switching to the next set of stack, so you know which file you're actually in. So lots of tools in here for checking stuff. You can do hashes, objects, and with objects you can call methods or directly access elements or arrays. You can do meta checks, such as, is this blessed, is this defined, is this an instance of whatever class? Is this type of ref? And all that stuff is baked in here. Diagnostics still need a little bit of work, but they're already incredibly useful. An event I didn't talk about, waiting. When your test suite is done, it issues a waiting event in the parent thread. And then it waits for all the child threads and child processes to exit before your main process exits. This actually fixes a problem that none of the concurrency tools for Test Builder currently solves. That is that if your parent process exits 0 before all your child processes exit, the harness will only see that and go, hey, your test passed, even if your children are off in the distance reporting failures. The harness, unless it sees those okays, it's just gonna say, oh yeah, it passed, it exited true, we're good. Test shared fork, the built-in concurrency support in Test Builder, none of this stuff catches this. This is actually a that will be fixed with the TestStream stuff, or is already fixed with the TestStream stuff. Parent process exits last. That is all I really had to talk about at the moment. So unless there are more questions, I'm going to go ahead and get down from this podium. By the way, I'm really approachable, so if you want to actually talk to me in person and feel safe asking a question out there, please come to me. I love talking.